Okay, good evening. We will continue with tutorial for today. Okay, so we'll be covering tutorial 1. Okay, so tutorial 1 will be more on the chapter 1 until chapter 3. So we will see whether I can give you a synchronous at puzzle tutorial 2 for your preparation for your uh, midterm test. Okay, so we are in week number 8, and next week will be mid semester break. And after mid semester break, we will be having midterm exam. Okay, midterm exam face to face in the campus, and you will be tested from chapter 1 until chapter 5. Okay, so we have covered chapter 1 until chapter 5. So I'm not entering chapter 6 this week so that I can do this tutorial and I can give you some exercise. Okay, based on tutorial. Okay, so in tutorial 1, there are various questions, okay, from chapter 1, chapter 2, and chapter 3. So you can do the test by yourself. Okay, do the exercise, and today we will be discussing some of the questions. So I just handpick a few, okay, so that we can have some discussion, and I can explain to you how you can answer and score in the exam. So not only midterm exam, even in the final. Okay, so you need to know, so the some of the things that we will be checking, and you must have a rough idea how you can answer. Okay, so today we will be covering tutorial 1. So I have selected, if I'm not mistaken, 6 questions. These 6 questions, some are very direct questions. Okay, so direct questions can be from the lecture notes. Okay, so make sure you understand whatever we have studied all this one. Okay, especially chapter 1, 2, and 3 is supposed to be covering the concepts and also the definitions. So you need to know, because all this will be frequently asked in the exam. Okay, so explain frequency modulation. So explain amplitude modulation. So what are the comparison? So all this we are not really covering, and you can see in the tutorial 1. Okay, some of the questions that you can answer by yourself. Okay, so you can use whatever resources that you have, and most of the exam they will be based on our lecture notes, because we are using lecture note to teach you. So we will be testing mostly from the lecture notes, and some of the questions will be based on whatever we have discussed, additional points that I have given during the lectures. So that's why I always encourage you to come to the class so that you can hear the extra inputs. Okay, so I frequently will ask the questions about the additional inputs. Okay, so if you never attend the class, so you will have struggle in answering whatever questions, because it's not really coming from the lecture note. Okay, so in the exam, so there can be some part that comes from the lecture note. Some part must is based on whatever I have explained, additional, and some based on your understanding and also your research by your own. Okay, so that's why when you answer the questions, so make sure you find additional inputs, because some questions it can be direct. If let's say 2 marks, so you can just answer like maybe in 2 lines. So maybe you add some figures, so you draw some figures, then you can get 2 marks. But the same questions at times can be asked for 5 marks or 7 marks. Then you can answer like how you answer for the 2 marks. So if you answer like you answer for the 2 marks, you only will get the 2 marks. So the remaining five will not be given, because your answer is not complete. Okay, so usually what I encourage the student, so the rule of thumb, okay, you if you have followed my class before this, so the rule of thumb usually for you to estimate, so 1 mark maybe 2 lines. I mean 2 lines of your answer, so it can be considered as 1 mark. So let's say the question is 5 marks, then you need to answer at least like 10 lines of answer, one paragraph. You can be considered to give more marks. Okay, so don't answer 5 marks question with just 2 lines. So it's only considered like 1 marks. And I always encourage the student, so draw some figures which is related, and make sure your paragraph and the figures are connected. Okay, so yeah, you must say, so refer to the figure 1. Okay, so figure 1 shows, okay, amplitude modulation. So let's say you draw something, then you show amplitude modulation. So then I can relate. So usually what student will do, they will just draw something and expect me to understand. So that is not the proper way, because sometimes I don't even understand what you draw unless you explain in the paragraph. So make sure when you draw, so you explain also in the paragraph what you draw about, and make sure the figures that you draw, you label it. You say, okay, so this is a carrier signal. So this is modulating signal. So this is a receiver. This is a transmitter. So make sure you label and you show properly. Okay, whatever you are showing. Okay, or explaining. Okay, so that is how you can earn more marks. So usually I encourage the student to write more. Okay, write more, because some maybe you give 4 sentences, maybe one sentence is not accurate. Then I will minus mark for that. But if you have more, so let's say you only write 4 sentences. The question only requires 4 sentences. So let's say you write for 6 sentences. So if one sentence is not accurate, so I minus mark. So maybe you can cover back by another two lines, 2 sentences. So that's why I always encourage to write as much as you can. Yes. So that's why when you want to write, you need to have the knowledge. That's why you need to understand whatever we are learning. So all the materials are given. Okay, lecture note is given, videos are given, okay, add puzzle assignments are given. Even in that puzzle assignments, we have some questions. Okay, because I just want to give you extra questions. So try to answer it. So not getting the answer from Google or Chat GPT and just put it there. So when when the real exam is there, so your Chat GPT or Google will not help you. Okay, so you need to understand, or you need to understand how to answer that particular question. Okay, so that's on the general, how you can prepare yourself for your assessment or your midterm test or your final exam. Okay, so midterm, yeah, we will have 2 questions. Okay, 2 questions. So question 1 will have 2 parts, A and B. Question 2 will have 2 parts, A and B. Okay, or maybe the most will be 3 parts. Okay, but only 2 questions. So will be given 1 hour. Okay, 1 hour to answer. So once you answer, then you can submit the question. Okay, so if the question relating to calculation, maybe I will give some appendix or formula. If it's very general formula, then I expect you to memorize. Okay, so not many parts on calculation. Okay, so we enter to tutorial 1. Okay, so tutorial 1 will be covering a few questions from chapter 1, 2, and 3. Okay, so basic questions like this can be asked. What are the 3 main parts of the communication system? Okay, so communication system, we know. Okay, this is from chapter 1. So communication system consists of various parts. Okay, so various parts, and it has 3 main parts. So main parts meaning the parts must be there. You cannot eliminate. Okay, at times, like amplifier. So amplifier is optional. So that is not the main part. It's the optional parts. Okay, so read the question properly. So what are the three main parts? So questions say main parts of a communication system. So you need to understand that the communication system must have a transmitter. Okay, transmitter, it will receive the message, it will convert it, modulate it, and transmit it to the receiver through a channel. So these three parts are really important, okay, for a communication system. So communication system must have a transmitter, must have a receiver, and to communicate these two, it must have a channel. Okay, so must have a channel. Okay, so all these three are the three main components of a communication system. The message signal is modulated by the transmitter. Okay, so the transmitter will have all the circuit to modulate. So modulate means package the message signal. Uh, so I have told you before. So if you want to go from Kanga to Kuala Lumpur, you can walk, but it will take a very long time. So we will get into a car. So this modulation is like you getting into the car and you drive to Kuala Lumpur. Okay, so that is what we call as a modulation. So the message signal will be joined with the carrier signal. We call it as a modulation, and it will be done by the transmission circuit. Okay, so transmission circuit. Okay, so the process of transforming a signal into a form appropriate for transmission is known as modulation. Okay, so if you have this kind of question, so let's say it's only three marks. Okay, 3 marks, maybe they will expect you to explain maybe in one line of transmitter, one line about channel, and one line about receiver. If it's 5 marks, maybe you can draw the block diagram. Okay, so you can refer back to lecture 1. Okay, chapter 1. So you can draw the block diagram. So you can say, so okay, this is transmitter. So this is the receiver. This is the channel. So when you draw, so you might, if the drawing is accurate, so you can get 1 mark. Okay, so try to earn as much as possible. Okay, so don't only see like, okay, so this is 3 marks. So I only want to answer 6 lines. Uh, so don't, maybe try to have some additional info inside, so that even though you lose mark in one part, I can give you marks in other part. Okay, so my role here is to give you marks. Okay, if you answer it properly. Okay, provided you answer it properly. If the answer is inaccurate, so I cannot give marks. So you need to understand. Okay, so try to help me, then I can try. I can help you. Okay, so that is first question. Okay, what are the three main parts of a communication system? So explain it properly. Okay, so always see how many marks are given. So if 5 marks or 4 marks, so explain more. Okay, so if 2 marks, 1 mark, or 3 marks, so maybe you can have a moderate answer. Okay, so that's for the first one. Second question, so is another basic question also. What is a wireless communication system? Okay, so the question say, what is the meaning? You need to explain how the wireless communication system function. So how you can define. So what is a very general question. Okay, so very general. So you can explain a lot of things. Okay, so if the question say explain the advantage of a wireless communication system, so it's already narrowed down. So you cannot discuss disadvantages. But if the question is what is something, then you can explain a lot of things. Okay, so it's quite open. Okay, so answer given here: wireless communication system uses free space for the transmission of signal. Okay, so wireless, you can compare it with wired. So wired is between a connected cable, okay, or wire, and wireless, you use a free space. Okay, free space can be anything. It can be in between buildings, it can be in between cities, so it can be in between skies. Okay, so like a satellite communication. Okay, so you can have wireless communication system in various stages. Okay, so you can explain all that. Okay, so the main thing about wireless communication system, you are using a free space. Okay, so read the question properly. Read the question properly. How you should answer. Okay, when you read the question, you already can imagine. So how you want to answer. So make a point, then you explain. Okay, so I don't prefer people answer in point form. Okay, please answer in paragraphs. Okay, so don't answer in point form. Okay, so I repeat again. Okay, don't answer in point form, because last time I got tell the other students as well, but when they answer in point form, so I can the sentences are incomplete, so I cannot give full marks. Okay, so I need to be fair for those who answer in a paragraph form. Okay, so make sure in the exam answer it in a paragraph form. So like this, so you answer in a paragraph form. So maybe you can have points down there, but the main the points that you have listed down in a bullet, you need to answer it in a paragraph, and then you can get full mark. Okay, so the wireless communication system uses free space for the transmission of signal, so you must mention about the free space. Okay. Okay, the electrical signal is modulated and transmitted through free space, and receiving transducers convert an electrical signal into physical equivalent. So, for example, so because the question is what is, so you can explain a lot of things. Okay, so like here they say you are using free space. So how the modulation and demodulation happen. So modulation happen in the transmission circuit, and demodulation happen in the receiving circuit. So you can, it will be good if you can draw something, some sketch or some block diagram to show how the wireless communication is going through. Okay, so transducers convert the electrical signal into physical quantity. Physical quantity can be acoustic, like loudspeakers. It can be another mechanical energy, so or mechanical signal, or it can be electrical signal. So it can be anything. Okay. So as long for wireless communication system, it has a free space in between, and the communication happen in the free space. Okay, so that's for the second question. Okay, any questions so far? Question 1 and question 2. Anything that you have query about? That's one.
Sir.
Yes.
So let's say, because these are general questions, but they have like they have their own set of things you need to include in the answer.
Yeah.
But let's say like we forget the specifics. Is it okay if we use layman terms to describe like the question, or like what the question wants?
Okay, so it depends on the questions also. Because if the question is a bit technical, so we expect you to answer it uh, as an engineer. So you need to answer it in a technical term also. But if in some case that you miss certain terms, then you can answer it in a layman term, but provided so the overall context is still technical. So you cannot answer everything in layman term. Okay, maybe these questions, if the previous question, so you say about uh, communication system, so you cannot answer this in a layman term also, because three main parts. So if the question asks what is communication system, then you can answer it in a layman term, because it's more open. So other fields also using communication system, but when it says about three main parts of the communication system, then it's already entering into the technical side. So we expect you to answer in a technical way. Did I answer you?
Yes, I thank you.
Okay. So any other question? before we move to other questions. Okay, so I guess no. Okay, question number 3. Okay, so what is the advantage of a frequency modulation over amplitude modulation? So if you see this question, they already say you must discuss the advantage of frequency modulation. So don't discuss disadvantage. And you want to highlight that frequency modulation is better than amplitude modulation. So the scope is already given. So make sure you answer within the scope. So don't write something else which is not relevant, because the marks will be given for the comparison of frequency modulation with amplitude modulation, and you must highlight the advantage of frequency modulation. So you must know your stuff. Okay, like this question is already narrowed down, so you cannot twist and turn the question. Okay, so the answer here, like this, is given in a bullet form. So and don't give in a bullet form. So I explain in a paragraph. Okay, paragraph. Okay, so you can see some of the advantages are mentioned here. Okay, so frequency modulation receivers may be fitted with amplitude limiters to remove the amplitude variation caused by noise. So amplitude limiters are like filters. Okay, so it will filter the amplitude. So higher amplitude, it will cut or normalize. Okay, so when it does that, so you can reduce the noise. Okay, so this make a frequency modulation reception more immune to noise than amplitude modulation reception. So that is one advantage of frequency modulation over amplitude modulation, because amplitude modulation, it has a lot of noise. Okay, because it's varying the amplitude. But when you are varying frequency, so you're actually varying something which is hidden. Okay, we cannot really see or observe a frequency difference. Okay, unless you are very sensitive. But amplitude, you see some changes, you already can understand what the changes about. Okay, so that's why it makes FM have a better immune to noise than AM. So that's why nowadays we are not really using amplitude modulation unless certain application. Okay, because we want to eliminate the noise. Okay, then second point, it is possible to reduce noise by increasing the frequency deviation. So you can play around with the frequencies. Okay, so you can change the variation, you can do a lot of filtering to particularly only take certain frequencies. Okay, so this is a feature that AM does not have, because it is not possible to exceed 100% modulation without causing severe distortion. Okay, so distortion, we know some changes in the original signal or some kind like an error. Okay, so it's always happen in amplitude modulation. Okay, so we can reduce the noise further by increasing the frequency deviation. So because frequency, it can be uh, over a very large band. So we have seen they are very small frequency band, narrow band. So we can have a wide band. So we can have a ultra uh, UHF, ultra high frequency, very high frequency. So a lot of frequency variation that we can utilize, and it can reduce the noise. Okay, and third one, standard frequency allocation provide a guard band between commercial FM station. Due to this, there is less adjacent channel interference than in AM. Okay, so this is for your radio, okay, FM radio. So in certain frequency, different radio stations can operate. Okay, so in between the frequency, So the F something called as a guard band. The guard band, so it's like a guard to prevent. So station 1, the frequency overlap with station 2. So the guard band, so no station will be allowed to operate in these guard bands. Okay, it's already predetermined. Okay, so due to this, there's less adjacent channel interference than in AM. Everything you need to compare with AM. Okay, so you can see here they compare. So interference, here they compare distortion, and here they compare noise. Okay, so you must read the question first. Take time in reading the question. Okay, so this is question number 3. So explain in a paragraph form. Okay, number 4. Why is modulation used? Okay, so you need to explain the reason. Okay, so it's already mentioned why. So directly explain. Okay, modulation is used for is following advantages. So modulation of course have a advantage. Okay, advantage over other methods. Okay, so modulation, what are the advantages? So reduction in antenna height. Okay, so physical antenna. So we can see normally the antenna will be certain heights. If the modulation is not happening, so you need to have very high antenna construction. Okay, construction when the antenna is very high, so automatically the cost will be higher, and it can be the structure must be really stable. It must be withstanding the geographical changes. So it must be it must withstand the climate changes. So a lot of things. So our aim is to have a shorter antenna but better frequency transmission. Okay, that is our aim. Okay, so reduction in antenna height is possible when you are using modulation, because modulation you already package it nicely and you are sending. Okay, so imagine you are sending Aromanis mango to Kuala Lumpur without packaging. How it will be? So when you package it nicely, it will reach the receiver in a better form, in a good form. So that is the function. Okay, the second one, avoid mixing of signal. So earlier we have seen how the guard band functions. Okay, and FM is utilizing the frequency variations. AM is using the amplitude variations. But the main idea of modulation is we don't want to mix the signal. Okay, so that's the second advantage. The third advantage increases the range of communication. Okay, when you modulate it, you can make it travel to certain distance, okay, better distance. So imagine if you only have no modulation, so you need to have two eye antennas for it to communicate. So and it must be very near. So you cannot withstand. So because of geographical location, so it cannot pass through high buildings. It cannot pass through hills or mountains. So it will have uh, unflexibility. Okay, so we want to increase the range of communication. It's possible using a modulation. Then multiplexing is possible. So multiplexing, so you are combining few signal into one signal, and you will have demarks in the other end to make it. So let's say you want to send 10 signal at one time. So you have a multiplexing circuit to combine the 10 signal into one. You modulate, you send, and the receiving end you will have a demarks, so multiplexer to change it from 1 to 10 channel. So it is possible. Okay, and the fifth one is improve quality of the reception. So of course, at the end, our quality matters. So we want to prevent. So when you have all these advantages, automatically the quality of reception will be higher. So that will help you with delivering whatever you want to deliver. Okay, so any question for question 3 and 4? Okay, so these questions, so don't answer in this form also. Explain in a paragraph. Explain in a paragraph. So let's say this question has 5 marks because you have 5 points. So 5 marks. So each point you explain in 2 lines. So you can have 10. So 5 times 2. So you can have at least 10 lines of answers. Okay, and make sure 10 lines of answer is just a rule of thumb. So it's not fixed like that. So you just estimate if your writing is small, then in one line you can have more words. Yeah, but if your writing is bigger, then you can add few more. So instead of 10 lines, maybe you can write 14 lines because your writing is bigger. Okay, so you can estimate that. Is there any question? Question 3 and 4. Okay, so no question. Okay, so we will see 2 calculation question. Okay, for you to understand. Okay, so this is from modulation, so it's chapter 2. Okay, so number 5, the modulating signal. Okay, usually the modulating signal. So what is modulating signal? Okay, who can answer? Modulating signal. What is modulating signal? So before you answer this kind of question, you need to understand the terms first. So what is modulating signal? Anyone?
Modulating signal is a message signal plus carrier signal.
Okay.
Isn't that modulated signal?
Okay, so I will explain it. It's okay. A good try. Thank you. So any other answer? Modulating signal. What is modulating signal? Anyone?
Isn't modulating signal is the signal used to modulate a carrier signal? Is to mix with the signal.
Okay.
To mask it.
Yeah. Okay. So please, if you are taking notes, please write it down. Modulating signal is message signal. Okay. Don't ask me why they have almost similar names. So modulating signal is actually message signal. Okay. So sometimes they use this term modulating signal. So usually in modulation, we will see 3 types of signal. First one is modulating signal or message signal. So that is number 1. Okay, so at times it will be written message signal. So if it's written message signal, so then you understand. So it's very clear. But if they use the term modulating signal, please understand that it is message signal. Okay, so don't confuse that it is a combination of carrier. No. Okay, so that's the first signal, the modulating signal or message signal. The second signal is carrier signal. The carrier signal. So carrier signal is the carrier wave, so generated by the oscillators. Okay. So for example, so modulating signal or message signal is yourself. So like I give the example, you want to go to KL. Okay. So modulating signal or message signal is you. Okay, you want to go to KL. So you are the commodity. Okay, you are the matter. Okay. So carrier signal is your car. So let's say you want to go to KL. So you can take a car, you can take a motorbike if you want. So you can take a bus, you can take a flight. So the transportation is the carrier signal. Okay, it carries you. So carries your message. Okay, so carrier signal. Okay, and the third one is modulated signal. So modulated. Modulated. A modulated signal is combination of modulating signal with carrier signal, or message signal with carrier signal. So both are the same. Okay, you combine together, it will give you the modulated signal. So make sure you understand the terms. Okay, so in this case, so they say the modulating signal 25 cos 2 pi times 105t. So what is referring to? Okay, so what is referring to? Modulating signal. Is it number 1, number 2, or number 3? 3 types of signal. Any answer? No answer?
Not sure, sir.
Okay, so modulating signal is actually referring to message signal. Okay, so message signal. Okay, you understand, Anna? Okay, maybe I just write it in the chat. Okay, so you can refer to the chat. Okay, so this is the first type, modulating signal or message signal. So that is your message. Okay, both are referring to the same. Okay, then second one, carrier signal. So carrier signal is the transportation. Okay, transportation of your message signal, or it will combine with message signal to form a modulated signal. Okay, the third one, okay, modulated signal is modulating signal plus carrier signal. Okay, now you all get it? Understand?
Yes, sir.
Okay. Okay, so in this case, so what is referring to? Modulating signal.
Modulating signal referring to the message signal.
So that is your message signal. Okay. So if you find this term in your exam paper, so just cut and write message signal so that you won't get confused, or you just like highlight, so put a remark so that you won't confuse yourself. Okay, so you have here a modulating signal. So the modulating signal is 25 cos 2 pi times the 105t is used to modulate a carrier signal. So carrier signal is given 50 cos 2 pi times 160. So they asked to find the modulation index, percentage of modulation, frequencies of sideband components, and their amplitude. And they asked to find the bandwidth. Okay, 5 things they asked to find. Okay, so we see how to answer this. Okay, so first you write it down. What you want to find. Okay, first one is modulation index. The modulation index is mu. Okay, mu. Okay, and second one is percentage of modulation. The percentage mu. Third one is frequency of sideband component. So we can write it. So sideband component. So usually it will have 2 sidebands. Okay, one is upper sideband and lower sideband. So F USB is frequency of upper sideband, and F LSB is frequency of lower sideband. Okay, then you find the amplitude of each sideband, and number 5 is the bandwidth of the modulated. So you can see modulated signal. So modulated signal is referring to
The modulating signal and carrier signal.
okay, so it's a combination. Okay, so I hope you understand now the differences between these three. Okay, so some of the formulas that you will use for this question. So the first formula is this formula, so you can refer to chapter 2. Okay, so MT. So MT is message signal. Okay, MT. So CT is carrier signal. Okay, you need to understand these two. Okay, so first message signal equals to, so this is the standard form, AM cos 2 pi FM. FM is modulating signal frequency, FMT. Okay, so earlier in this question, they say modulating signal is 25 cos 2 pi times 105t. So you just write it down and you compare. So based on this comparison, what is the value of AM?
25.
25.
25. So direct comparison. So AM is 25 cos 2 pi, so FMT. So FMT is here, 2 pi is here. FM is
10 to the power of 5.
okay. Sorry, this is 10 to power of 5. Sorry, wait, it's not going up. Okay. Okay, so this is the correct one. Sorry earlier. Okay, but in your tutorial, you left the correct one. Can you see? Is it changing?
No, sir.
No, sir.
Let's hold on. Publish again. Okay, so please change this. This part. Okay, so 10 to power of 5 and 10 to power of 6. Okay, not under 5. Huh? Okay. So, what is the value of FM? Value of FM.
FM is 10 to the power of 5.
Okay, 10 to power of 5. So, direct comparison. Okay, so CT is carrier signal. So, the formula is AC cos 2 pi FC. FC is carrier frequency. So, 2 pi FCT. Okay, and in the questions is given, so carrier signal is 50 cos 2 pi times 10 to power of 60. Okay, so you just write it down, you compare. What is the value of AC?
50.
Okay, 50. So what's the value of FC?
10 to the power of 6.
Okay, 10 to power of 6. Okay, so that's the first comparison, and this is the formula to calculate the modulation index. So because you need to find the modulation index, okay, and this is the formula for bandwidth. So bandwidth equals to 2 FM. Okay, so all this formula we will be using in solving. Okay, so this is the answer. Okay, so we just cover this first. Okay, the modulating signals, MT, so we already wrote it down. So MT equals to AM cos 2 pi FMT. So this is the comparison. From here we know AM is 25. Okay, so AM is 25 volt. So FM is 10 to power of 5 hertz. So it's equals to 100,000 hertz or 100 kilohertz. Okay, so that is for modulating signal. Then the carrier signal. Okay, so CT equals to AC cos 2 pi FCT. So 50 cos 2 pi times 10 to power of 60. So AC is 50 volt, FC is 10 to power of 6 hertz. So equals to 1 million hertz equals to 1000 kilohertz. Okay, so that's the values that we have gotten. Then the first they asked to find, the question asked to find modulation index. Okay, so you find the modulation index, mu. So mu equals to AM over AC. So that's the formula. So mu equals to AM over AC. So AM and AC, the value already found. So AM is 25, AC is 50. Okay, so 25 divided by 50 is 0.5. Okay, so no unit because it's a ratio. Okay, so percentage of modulation. So percentage mu. Percentage of modulation is modulation index times 100. Okay, because we want to make it 100%. Okay, you want to reflect with 100%. So 0.5 times 100. So it is percentage of modulation. You need to write it in a percentage, 50%. Okay, so frequency of sideband. So that's the second one. So third one. So it asks to find the frequency of sideband component, FUSB and FLSB. Okay, so you want to find. Okay, first the formula to find FUSB. So frequency of upper sideband. So the formula is FC plus FM. Okay, so the formula to calculate FLSB, so lower sideband frequency, FC minus FM. Okay, so the value of FC and FM, we already got it here. Okay, these two. So we know FC is 1000 kilohertz. So 1000 kilohertz plus FM. FM is 100 kilohertz. So then you get 1100 kilohertz. So that is the frequency of upper sideband. And frequency of lower sideband, so formula is FC minus FM. So FC is 1000, okay, 1000 kilohertz minus 100 kilohertz. Then you get 900 kilohertz. Okay, so you already found the frequencies of the sideband. So amplitude of each sideband. Okay, so the formula is two times the amplitude equals to mu AC. Okay, that is the formula. So since we want to find the amplitude of each sideband, so you need to use this formula, mu AC divided by 2, because you only want to find for one sideband. Okay, so divide by 2. Okay, so mu is 0.5, AC is 50. So 0.5 times 50 divided by 2. Okay, so you get the answer. The amplitude of sideband is 12.5 volt. Okay, so you already found 4 answers. Then the last one, you asked to find the bandwidth of the modulated signal. Okay, bandwidth of the modulated signal. So you use this formula. Bandwidth equals to 2 times FM. Okay, so 2 FM is 2 times 100 kilohertz. So FM is 100 kilohertz. So is 200 kilohertz. Okay, so by answering this, you already managed to answer all this. Okay, 5. Yes, so this kind of questions easily can be like 6 or 7 marks. Okay, because it's stages. Okay, stages. So you need to understand. It's not so complicated if you really understand the concept. Okay, so make sure you understand how it is done. Okay, make sure you don't skip any steps. Okay, so then you can score marks. Okay, so any questions or question number 5? Any question? Understand how it is done?
Yes, doctor.
Okay. So we move to one final question for today. Okay, the rest I will give you in the tutorial, so you can do by your own. So if you have question, you can ask in the group. Okay, so number 6. Yeah, this is another question. It's amplitude modulation. So almost similar, but it has more branches. Okay, so we just read an audio signal 15 sine 2 pi 1500 t. So this is a audio signal. So if it says audio signal, meaning is a message signal. Okay, message signal. So 15 sine 2 pi 1500 t amplitude modulates a carrier. So carrier signal is given 60 sine 2 pi times 100,000 t. Okay, so here they ask. So this is not a. It's just like a design. So just ignore this line. Okay, first they ask to sketch the waveform of an audio signal. Okay, so the first three A, B, C are sketches. Okay, you need to sketch. First, you need to sketch the message signal, which is the audio signal. Second is the carrier signal, and third is the modulated wave. So modulated wave signal means after you combine message signal with carrier signal. Okay. So first I just show you how these three are done, okay, because it involves sketch. Okay, so first we want to find out what is the audio signal. So audio signal or the message signal or the modulating signal. So all these three names are the same. Okay, so the same. So here they given 15 sine 2 pi 1500 t. Okay, so it's given here. Okay, so you compare with the standard formula. So mt equals to am sine 2 pi fmt. Okay, from here we know am is 15, am is 15 ohm. Okay, fm is 1500. Okay, so 1500. So carrier signal ct so equals to 60 sine 2 pi 100,000 t. So compare with the standard formula, Ct equals to AC sine 2 pi fct. Okay, so AC is 60. Okay, AC is 60. So FC is 100,000. Okay, so these are the information you can get from the question. Okay, first you draw the audio signal. Okay, audio signal, how you draw? So you just have this is the waveform. So this is your y-axis, this is your x-axis. Okay, so first you see what is the amplitude of modulation, 15 volt. Okay, so first you need to draw 15 here, 15 volt and negative 15 volt. And in between, so you have a sine wave. A sine wave. So the top one is 15, the bottom one is negative 15. So the signal will go in this form. Okay, this is a sine wave. Sine wave meaning it starts from 0. Okay, so that is how you draw your message signal. Okay, so it's only depending on your AM. Okay, AM amplitude of the modulating signal, 15 volt. So it cannot be lesser or more than 15 volt for the peak. Okay, so understand this, how you draw. Can you understand?
Yes.
Okay. Okay, the second one. So carrier signal. Okay, so carrier signal we know AC is 60 volt. Okay, 60 volt. So similarly, you draw carrier signal. So carrier signal, so maximum is 60 volt, minimum is negative 60. So automatic. So once you know here 60, so this is the maximum. The minimum is just the mirror of it. Okay, so negative 60. So you draw at the y-axis and also x-axis. Then you have all these plots as a grid. Then you start from 0, you go. Okay, so make sure in one period, so you have few. Okay, one cycle you have a few lines. So here is only F. It's a bit like distant. Okay, but here within one box you can see, so it's going 2 or 3 times. Okay, so the main idea of carrier signal is, but it must be oscillating between 60 to -60 for this case. Okay, so just have more signals between these boxes. Okay, and once you join, so the modulated signal, the third part. Okay, so here a bit like you need to understand. Okay, first because you need to combine this with this. Okay, so what first you draw? Okay, so here we know the carrier signal is 60. Okay, carrier signal is 60. So the message, the modulation will start from 60 and -60. So I just draw on the positive side, so you just mirror it down here. Okay, so first 60. Okay, so you start from 60. So we know it go up to 70, up to 15. So the positive. So you just need to translate this into this. So meaning 60, it go maximum until 75 plus 15. Then it goes down to my 60 minus 15 is 45. So it will oscillate here. Okay. So this waveform is actually this waveform. Okay, so similarly here on the opposite direction, so -60, so it goes until -75, then goes up until -45, then it will go down. Okay, so once you have this as an envelope, then in between you just draw the same carrier signal in between. Okay, so you just draw in between. So by referring this, so we can draw the message signal, so carrier signal, and also modulated signal. Okay, so I will give you assignment 1 regarding this, so you can have a better understanding when you try. Okay, so after that, find the modulation index and percentage of modulation. So determine the frequencies of audio signal and the carrier signal, and frequency of the present spectrum. Okay, all these are similar like the other earlier we have seen. Okay, number D, find the modulation index and percentage of modulation. So modulation index mu is AM over AC. So AM here is 15 volt, AC is 60. So we know 15 divided by 60, so equals to 0.25. So percentage of modulation is modulation index times 100. So percentage must give in percentage, 25%. Okay, so E, determine the frequencies of the audio signal and carrier signal. So audio signal, so we have this formula, mt equals to 15 sine 2 pi 1500 t. So you just need to find the value of fm. Okay, so direct comparison, fm is 1500. Okay, 1500 hertz or 1.5 kilohertz. So carrier signal, you just compare directly. Okay, fc is 100,000. So 100,000 hertz equals to 100 kilohertz. Okay, so always give in kilohertz. Okay, so it will be better. Okay, and the last part, frequency present in the spectrum of the modulated signal. So similar, FUSB and FLSB. So use the same formula, FUSB equals to FC plus FM. So all these values are given. So 100 kilohertz plus 1.5 kilohertz. So you'll get 101.5 kilohertz for FUSB, and FLSB, so lower sideband frequency, FC minus FM. So 100 kilohertz minus 1.5 kilohertz. So you get 98.5 kilohertz. So all these three are same like question 5. Okay, so any question? Okay, sorry, 1 minute extra. Okay, so I just discussed few of the questions. So more calculation questions are there in the tutorial. So please try. So you have like 2 weeks for preparing for your midterm. So please try. So any question regarding these 6 questions? No questions? Okay, so please hold on.